All right, I am recording. Okay, so today we are going to continue solving systems of equations, but this time we're going to use a different method. We're going to use the substitution method. So this is an algebraic method. Yesterday, or in 5.1, what you guys did was solve by graphing. So you were looking for the intersection point. This time, what we're going to do is we're going to use algebra and find the intersection point. Okay, so let's take some notes. So when you are using the substitution method to solve systems, what you're doing is you're substituting one equation into the other equation. So I'll show what this looks like in a moment. So it's very important that you have one of the variables solved for. So either your equation is solved for x or your equation is solved for y. It doesn't matter. I always try and look for the naked variables because that makes it the easiest. So once you solve for a variable, you're going to substitute the one expression into the other equation. Okay? And then once you do that, you're going to solve for the variable, because once you substitute one expression into the other equation, you're only going to have one variable. You eliminated one of the other variable. So then let's say you get your x value, right? You're going to substitute that answer into your revised equation, and then you're going to solve. So let me show you what this looks like. Okay, so y is equal to this. So what I'm going to do is I'm going to substitute this expression in for that y. So if y is equal to this, that means I could take this whole entire thing and substitute it in for this y, because it means the same thing. All right, so 4x minus 1, I put it right there, is now equal to 2x minus 5. So all I did was combine, oh, wrong color, combine the two equations. Okay, now we're to a multi-step equation. We did this in unit 3. So now subtract 2x from both sides. So we have 2x minus 1 is equal to negative 5. Now we're going to add 1 to both sides. So 2x is equal to negative 4. Now we're going to divide 2 on both sides. So x is equal to negative 2, because a negative 4 divided by a positive 2 is a negative 2. Okay? So now that I have x is equal to negative 2, I'm going to plug this in for one of these x's. It doesn't matter which one, okay? So let's plug it in right here. Okay? So 2 times negative 2 minus 5 will give us our y. So let's plug in this negative 2 right there. And then you just do the math. 2 times negative 2 is negative 4. Negative 4 minus 5 is negative 9. So what does this mean? What does this mean? Well, what this means is my x-coordinate, if I were to write the answer, my x-coordinate is negative 2. My y-coordinate is negative 9. Okay, and let's see what this looks like if I were to substitute it back. Let's plug in negative 2 here. So 4 times negative 2 minus 1. Do I get negative 9? Yes. 2 times negative 2 minus 5. Do I get negative 9? Yes. So because this point makes both equations true, that will be your intersection point. Okay. So that's easy because they're both solved for y. What happens if they're not both solved for y? Well, what this means is I look for the naked variable. Okay? That is my naked variable. So if y is equal to this, I'm going to plug this in for y. Okay? So this expression is going to go into the other equation, and I'm going to combine them. So it's going to go in. So let's do this. So 3x plus 8, and then this is going to go in, equals negative 5. So I combine both equations. I also got rid of my y's. I'll do that. I'll deal with the y's later. So now, distribute. We learned this in Unit 1. Now, combine like terms. Now, subtract 72. So 11x is equal to negative 77. Negative 77 divided by 11, so negative divided by a positive, x is equal to negative 7. Okay, so I have two choices. I can plug this negative 7 for that x, or I can plug this negative 7 for that x. So let's think about this. Which one will result in the least amount of math? Which will get me the answer the quickest? Well, I think the top one, because all I have to do, all I have to do is plug in negative 7 here, add 9, and it spits out my y. It will give me my y. Remember that. So negative 7 plus 9 is 2. So y is equal to 2. Okay, so let's do this. My answer is, my x coordinate is negative 7. My y coordinate is positive 2. Okay, so let's see if this works. If I plug in negative 7 here, I get negative 21. Standard form is not helpful in checking my answers. So remember, negative 7 is going to go for my x. 2 is going to go for my y. Let's see what happens here. So negative 21 plus 16, does it equal negative 5? I believe so. Negative 21 plus 16 is negative 5. Also, I know it is equal to, it works here too, because negative 7 plus 9 is equal to 2. So since the point makes both equations true, it is the solution. And there you go. All right, so I want you guys to try 2 and 4. I'm going to get you started here. So if y is equal to 6x, plug it in for y. Here, they give us x. Our naked variable is x. So if x is equal to this expression, plug it in for x. So I'm going to get you started. 2x plus 3 equals negative 20. So you need to plug in what y is equal to here and solve. Now at the bottom one, 2x minus 6y equals 12. So you're going to take what x is, the expression, and plug it here. All right, go ahead. Okay, I'm going to do this very quickly now. So 6x goes here. So 2x plus 18x equals negative 20. Combine like terms. 20x equals negative 20. Divide by 20, x equals negative 1. Now I'm going to plug negative 1 here. 6 times negative 1. 6 times negative 1 equals negative 6. So my y is equal to negative 6. So y equals negative 6. And my x is equal to negative 1. Okay, this one, this expression, 4y plus 7, distribute, 8y plus 14 minus 6y equals 12. Combine like terms, I get 2y plus 14 equals 12. Subtract 14, I get negative 2 here equals 2y. And so y is equal to negative 1. So if y is equal to negative 1 here, I want to plug it into an equation where I do the least amount of work. I think it's going to be right there. So 4 times negative 1 plus 7 is equal to negative 4 plus 7. would be 3, right? So y equals 3. No, x equals 3. This was x. Oops. So x equals 3. See, I caught it because my colors help. So x equals 3. All right. So what I would like for you guys to do, oh, no, let me help you with 5. I'll help you with 5 and 6, and then you guys can do the rest. Okay, 5. I do not have a naked variable solved for, but I do see a naked variable right here. So what I'm going to do is I'm going to rewrite this top equation like this. Oh, I got negative 2x. What am I doing? I got to subtract the x term. Okay. So if y is equal to this, then I plug it in for y. Okay. So I'm going to let you guys get started. 5x plus 3y equals negative 8. So go ahead and get started. For number 6, my naked variable is the y again. So I'm going to solve for that y. So I have to subtract 2x from here. So this becomes y equals negative 2x plus 9. Okay. So if y is equal to this, let's plug it in for that y. So let's rewrite it. 2x minus 3, negative 2x plus 9 equals negative 11. So I combined, let me put that up here, 2x minus 2. So I combine them. Can you guys please find the intersection point? All right, so for 5, you should have gotten 2, negative 6. I'll look at your data and see how you did. 6, you should have gotten 2, 5. I'll look at your data and see how you did. Okay. So for 7 and 8, I see the naked variables are my x's. So I'm going to solve for x this time. All right, here we go. Subtract 5y from both sides. So x is equal to negative 5y plus 4. And here, x is equal to 0 minus 4y. So this should just be negative 4y. I don't need to include the 0. So now that I have my naked variable solved for, I'm going to plug it into the equations. So 3 times x plus 15y equals negative 1. I'm going to do 7 with you fully. So negative 5y plus 4. So distribute, negative 15y, distribute, that'd be 12 plus 15y equals negative 1. So when I combine these like terms, I get 12. These cancel out. So I get 12 is equal to negative 1. Well, that's impossible. 12 does not equal negative 1. It will never in any kind of circumstance. So if you get a situation like this, where the variable is gone and the left side does not equal the right side, this is an example of no solutions. These would be parallel lines. If you were to graph these babies, this would have been a two parallel lines. Okay. Can you try, please, to do 8? Okay, so if you went through and you multiplied, collected like terms, and solved, you should have gotten 8, negative 2. Oh, I keep forgetting my parentheses, don't I? Oops, bad, bad, bad. 8, negative 2. All right, I'm going to do 9 with you, and then you guys can do 10 and 11 on your own. So 9, where is my naked variable? My naked variable is right here. So I'm going to rewrite this as y equals negative 2x plus 18. Okay, so if y is equal to this, I'm going to plug it in for that y. Combine my two equations. So 6x plus 3y equals 54. And my y is negative 2x plus 18. Now it's time for me to distribute. 6x plus negative 6x. 3 times 20 is 60. Minus 6 would be 54. All right, combine like terms. These combine. Oh, they cancel out. So I get 54 is equal to 54. Well, of course 54 is equal to 54. So here's an example of infinite solutions, right? Because you have no more variables left. 54 is always going to be equal to 54. So this is an example of, this is the same line. If I were to graph these, you would get the same line. So let's just look at these two right here, okay? If everything cancels out and you get the left side is not equal to the right side, no solutions. If everything cancels out and the left side is equal to the right side, infinite solutions. Okay? You guys are on the hook for 10 and 11. Tomorrow, our independent work on the computer together will just be Delta Math. So you guys are going to work independently on the computer screen on a Delta Math assignment. I'll be there to help you if you get stuck. Okay? So 10 and 11, you guys are on your own. Go for it. All right, 10, you should have gotten negative 2, 0. And 11, you should have gotten negative 1, 5. All right, have a good day. I'll see you tomorrow.